Welcome and hello. This is a video exercise in HEC-RAS, and in this exercise, I'm going to be using rules with inline structures. Okay, so what that means is I'm going to create an inline structure with a gate and then use rules to operate that gate to achieve a desired outcome. All right, so let's get started here. I'll explain more of the details as we get going. The first thing we want to do is create a project. So go File, New Project, and then click on the directory that you want to save that project to, and then give that project a name. I'm just going to call this exercise 22, and then OK, and then click OK. First, I'm going to define the geometry file. So down here in the geometric data editor, you can access this by going Edit and then Geometric Data. I'm going to start by clicking River Reach, single left click at the upstream end of the reach, and then I'm just going to make a few more clicks here as I go downstream, and then finally a double click at the end. All right, I'm going to name this River A and Reach 1, and then click on Cross Section, this button on the left here, and then let's go ahead and add a new cross section. Let's start at River Station 0. This is going to be the bottom of the reach. I'm going to define the station and cross-section data right here by just pasting in some data I had saved on my clipboard from Excel. I copied it over, or you can just type it in yourselves. And then let's go with the distance downstream will be 0 because this is the cross-section at the bottom end of the reach. And then I'm just going to type in some values here that are typical Manning n values for n. And then the bank station is going to be at 100 and 250. Okay. Click Apply Data. Here is the cross section over here to the right. What I'm going to do is manually add a couple more cross sections and then do interpolation to add some more. All right, so to do that, I'm going to go up to Options and then copy the current cross section. I'm going to go ahead and put this at River Station 1000, so 1,000 feet upstream. And then what I also need to do is type in 1,000 feet downstream length to the next cross section. Everything else here can stay the same, and I also need to add some elevation so that the water flows in the correct direction. Adjust elevation, I'm going to add 2 feet, and then click Apply Data. All right, I need to go ahead and do that one more time for this exercise, and I'm going to copy the current cross section. This next one's going to be 5,000 will be the river station. So the distance downstream to the next cross section will be 4,000 feet. And I'm going to go ahead and add some elevation once again, and that's going to be 8 feet. So if I click Apply Data and then Plot Profile, we see a constant slope of 0.002 as the decimal, which is the same as 0.2%. Lastly, I want to add some interpolated cross sections at every 500 feet of the river station. So I'm going to close this and then go to Tools, Cross Section Interpolation within a reach. Here's the selected reach, and then it's going to be for all river stations. I can explicitly state all river stations if I wanted to actually fill in values there, and then type in 500 feet, interpolate, and close. All right, so this is our river reach and cross sections. Before I forget, I'm going to go File, Save Geometry Data. I'm just going to call this Base, and then OK. Next, what I want to do is add an inline structure. And what I'm going to do is I'm going to add that to River Station 950, which is just downstream of River Station 1000 here. So to do that, I'll click Inline Structure, and then I'm going to come up to Options, Add an Inline Structure. This is going to be at River Station 950, like I said. OK. Weir/embankment. Now this is where I'll define the distance downstream from the next upstream cross section is 50 feet. The width I'll also say is 50 feet. And then for the station elevation data, I'm going to just say that it comes up to this overbank elevation. So the station can be 0 to 350, or it needs to be at least 100 to 250. Yeah, let's do that actually. So 100, the elevation would be 42, and then 250, 42. I'll say there's a slide slope of 2 feet, or 2 to 1, and then OK. All right, so that filled in just right there. Lastly, I want to add a gate. I'll add a sluice gate just to the center here. I could get fancy and add multiple gates and multiple gate groups, but I want to keep this part of the exercise as simple as possible and just add one gate. All right, so I will use a gate coefficient of 0.5. The height is going to be 4 feet. The width will be 20 feet, and the invert is going to be at 33 feet. Down here, the number of gates, it's only going to be one gate, so I'll just say G1, and then that will have a station at 175, which should be centered within this embankment. So if I click OK, we have our gate right there. Okay, and I think that's good for our geometric data. So I'm going to close this and then File, Save Geometry Data. Next, I need to define the unsteady flow data. So I'm going to go up to Edit and then Unsteady Flow Data. I'm going to go ahead and first save this file. So Save Unsteady Flow Data. And what I'm going to call it is 100-500 underscore R1 open. First of all, open means open gates. And then 100-500 is the flow rate in CFS, random one. Okay, so let me just start working. This will make sense. The downstream boundary condition, I'll set that to the normal depth, and then I'll set the friction slope to the channel slope right there of 0.2%. And then as for the upstream boundary condition at river station 5000, I'm going to use flow hydrograph. And then off camera, I went ahead and created a random flow hydrograph of flows ranging from 100 to 500. That's the minimum and maximum value, but it starts at 300 CFS. So Control V to paste in that flow hydrograph. And then boom, this is what it looks like. So this is just randomly generated. It starts at 300, it dips down and never really gets back. But the minimum is about 180 and the max is 300 CFS. Okay, so let me close that. I'm going to use the 1 hour time interval. This is going to be a 3-day simulation, and I have about 3 days worth of data here. I'm also going to use the simulation time just so that this flow data starts at the same time as the simulation. Okay, so that's all I need to do there. Now the boundary condition for the gate, I'm going to click on rules, but I'm going to hold that off until a little bit later in the exercise. What I want to do here for this first trial is just to open the gates 100% of the way, which is the entire 4 feet of height of the gate, run the simulation with this random hydrograph, and then come back and set some objectives and then create some rules to satisfy those objectives. Okay, so this is going to be sort of our base case first. We'll come back, add the rules. But for now, I'm going to just go time series gate openings, change the time interval up to 1 day, or it could be anything, but I just don't want to have to type in the number 4 too many times. The gate's going to be fully open to the height of 4 feet, which is the height of the gate itself. So 100% open. And as before, I'm going to use enter table data and then use simulation time. I'll click OK to that and then File, Save Unsteady Flow Data. All right, it's time to run the model. So let's go ahead and create a plan. I'm going to click on the Run Unsteady Flow Analysis. Now in this dialog box, we have the base geometry and then our unsteady flow file we just created. I'm going to go ahead and save this plan. And I'm going to use the same name here as the flow data, 100-500 open. Okay, and then same thing for the short ID. I need to check on the different processes we're going to run, the programs. And then for the time window, I'm going to just use the first 3 days of January. So that's going to go from January 1st to January 4th. And then let's see, so for computation interval, 1 minute, that's fine. For the output hydrograph, I'm going to change this. Let's make it 15 minutes instead of 1 hour. And if we need more precise output data, we can come back and change this again. File, Save Plan, and Compute. Okay, so that ran. That looks good. Let's go ahead and take a look at some results real quick. Here's the cross-section at the inline structure. So you can see the gate is fully open and it will remain fully open for the entire simulation. So here's the first day. You can see the water surface is rising and lowering a little bit because it's a random hydrograph we input. It appears to be around water surface elevation 36, maybe a little bit less. Now, what I'm interested in here for this exercise is upstream at river station 1000. This is going to be the location or the cross section on the river that I want to control the water surface elevation. And what I'm going to do here is I'm going to say on the first day, I want the water surface elevation to be maintained at 36. On the second day, I want it to be 38. And then on the third day, I want it to be up to 40. So what I expect to happen is 50 feet downstream at that inline structure, I expect the gate to close at the beginning of the second day, or at least a little bit. So the water surface elevation increases at this cross section at river station 1000 so that we maintain a river water surface elevation of 38. And then at the beginning of day 3, it would do the same thing. So the water surface rises to a constant or near constant value of 40 feet. All right, so let's get started with that. I'm going to go back to the edit menu and then unsteady flow data. Now what I'm going to do is save a copy of this as a new name. So I'm going to go File, Save Unsteady Flow Data as, And instead of open, I'm going to just call this rules and then click OK. All right, now instead of the gate being based on the time series control, I'm going to click on rules, say yes, I'm ready to insert some new data here. And now I'm ready to insert some rule data to control the gates using these rules. The gate open rate, I'm going to say it's 1 foot per minute, and close rate 1 foot per minute. I'm just making up numbers here. The max opening will be 4, the min opening will be 0, and then the initial opening, I'll say it starts fully open at a height of 4 feet. All right, so we're done with that. Let's go ahead and start entering the rules. All right, so let's start off by getting a variable for the number of the day. So the first January 1st will be day 1, January 2nd will be day 2 and 3 and so on. So I'm going to actually add comments to my code just to kind of add labels and be a little bit extra explicit with what I'm doing. This first comment is going to be for the name of the variable. It's going to be day number. Next, I'm going to get sim value. So I'm going to click on the next row down, get sim value, and then click on time. And then let's see, a new variable is going to be called day number. And then what I want is the day of the year because I'm going to start the simulation on January 1st, and beginning of time step is exactly what I want. All right. So we got that variable defined. Next, I'm going to create a variable for the water surface elevation at River Station 1000. This is the location that we're going to use as a target. This is our river station of focus. So I'm going to, again, add a comment here. You don't have to add all these comments, but I'm just going to try doing it for now. The variable is going to be called water surface elevation at River Station 1000. And then in line 4 here, I'm going to click on get sim value. This is going to be a new variable again. So I'm just going to paste in or type in what the variable name is. Now I'm going to collapse this time category of variables, and I'm going to expand the cross-section category of variables. And what I want is water surface elevation, this first one right here, River A, reach 1, but this is going to be River Station 1000, okay, for the current time step. All right, so that right there, perfect. Next up, I want to define the target water surface elevation. So what this is going to be is, here, let me add the comment. So this is the name of the variable. What this is going to be is I want it to be set to 36 on the first day, 38 on the second day, and 40 on the third day. Now, I could be using branching if-else statements, but I thought it'd be a little bit more elegant to use a math function. So the new variable is going to be named water surface elevation, river station 1000. And then for the expression, this is going to be, it increases 2 feet per day. It's going to be based on the day number of the year. So if day 1 is 2 plus, it wants to be 36, we'll say 34 right here. I think that's correct. So on day 1, it'll be 36. On day 2, it'll be 38. Day 3, it'll be 40. Okay, nice. All right, time to define another variable. This time it's going to be the gate height. So I'm going to start with a comment. In line 8 here, I want to get sim value. This is another value that we can pluck out of the simulation at the beginning of the time step. It's going to be a new variable. It's going to be called gate height. And then let me collapse this. I want inline structure here is the category. And then let me just scroll down to gate opening right here. Now we need to make sure it's River A, Reach 1, River Station. It's my only inline structure, and it's my only gate group as well. So this is exactly what I want. All right, on to the next variable. This is going to be gate height new. That's what I'm calling this variable, gate height new. And this variable is going to store the value of the height we want to set the gate to. Now, it may be the exact same thing as the gate height, meaning no change. However, we may want to increase the gate height or decrease the gate height based on the difference between the water surface elevation and the target. Okay, so I clicked math. I've entered the new variable name right here. And then for expression, I'm going to go ahead and set this to the variable, and it's going to be called gate height. Okay. So this is just to initialize the gate height, so it has a value, which is based on this right here. So I guess I could have saved the line and just assigned it to this right here, whatever. Now I'm going to use this branching if-else construct. So I'll click on line 11 and then click on branch if-else. I'm going to use this first radio button, which is if condition then. And just so I don't forget, I'm going to come down to the next line and then click on the end if statement. All right. So those two are ready to go. Next, I'm going to come back to this if statement and define the expression. So edit, And what I want to do is compare the water surface elevation with the target water surface elevation. So if the water surface elevation at River Station 1000 is greater than the water surface elevation at the target water surface elevation, and then let me add a little bit of a buffer range so it's not changing every single time step. I'll say 0.1 feet. That'll be kind of the tolerance, if you will, or rather half the tolerance. So, okay. Then what I'm going to do is put my cursor down on the end if. So when I click a button that'll insert a new rule line, I'm going to set that gate height a little bit higher. Yes, I'm going to set the gate height a little bit higher. That way the water surface will lower a little bit. So I'm going to go math. This time I'm going to select existing variables and I want to select gate height new. That should be on my list and there it is. So I'm going to set gate height new equals gate height new and then plus 0.1 feet and click OK. I need to do the same thing in the opposite direction. So for instance, if it's less than the target and then maybe another 0.1 feet, then I can lower the gate. That way the water surface will increase a little bit. So what I'm going to do is select this row 11, hold down the shift key, then select row 13. That selects both rows plus all intervening rows, i.e. row 12 or line 12, and then click on copy, put the cursor on row 14, and then paste. All right, that just saved a couple of clicks for me. What I'm going to do is just change this to a less than, and then edit this expression, and then change the 0.1 to a negative 0.1, and OK. And then right down here for the actual gate height new, I need to change this to be -1 or minus 0.1. Okay. All right, we're almost done with building this rule set here. I'm going to select line 17, add a comment, and then this is going to be called adjust gate. This is not a variable. This is just a note. This is what we're doing next, starting on row 18. So I'm going to scroll down, click row 18. Now I'm going to click on this set operational parameter. And again, it's referring to the gate in the lateral structure. So what I want to do is go down to gate and then opening. And I want to set this gate opening to the variable we just calculated, which is our gate height new. So gate height new and OK. I also need to specify the gate group right there. All right, I think that's all we need to do for our setting up our rule for the inline structure. Let's go ahead and see what happens here. Go OK, OK. This is make sure to save it. So file, save unsteady flow data. I can go ahead and close this. Let's go back to, already got it open here, the unsteady flow analysis. It's using the base geometry, but now it's selected the unsteady flow file that we just created using the rules. Okay, so I'm going to save this plan and it's going to be saved the same thing except rules instead of open. So basically the same name here as the flow data file. Okay, same for the short ID. Okay, and let's click compute. Okay, looks all right. I saw an error message, so let me just see what this is about. Okay, so there's something wrong at River Station 500. That's the downstream of the inline structure. Let me take a quick look at that first. So cross section and then 500, and I'm going to go ahead and animate it. All right, so animate. So the water just looks fine. The water surface elevation is right around 32, 33. It looks like it hit bottom there for a moment though. Oh yeah, okay, I think I know what's happening. Let me back up here. This probably happens at the beginning of day 2. So this is 10 o'clock, 10:30, 11 o'clock, 11:30, midnight. Yeah, so for a couple time steps right there, at the beginning of day 2, it's shutting the gate completely at the inline structure. So what I need to do is set a minimum at the inline structure. So it's always going to be slightly open. It isn't completely shut off. So that there's always a little bit of flow downstream of the inline structure. All right, that's just a stability issue. Shouldn't be a problem. Let's go ahead and look at the inline structure now, and then let's go ahead and run the animation. So it starts fully open. If I click play here, we can see the gate closes. The water surface elevation is right here, and then it increases. The gate is just opening and closing, and then it's fully, okay, we have some instability on day 3, it looks like. Let's let's confirm that that's a problem here. This, yeah, on day 3 we have some problems. The gate was changing too much and it was going out of control. I'm going to do 2 things. I'm going to go ahead and take a look at the water surface elevation at River Station 1000 because this is the focus of our exercise here. I'm going to go ahead and animate days 1 and 2 should look fine though. It will start out an elevation of 36 feet. So we'll click play. All right, so it's 36 feet. And then on day 2, it should bump up to 38. There it is. So now it's at 38. And then on day 3, we have some problems with stability. And this is where it goes kind of crazy. All right, so I'm going to do two things. First of all, I'm going to set a minimum gate height of maybe 1 foot. That way there's always going to be some water flowing underneath. And then secondly, I'm going to change the step so that it won't change zero point 0.1 foot per time step. So let's go back to our unsteady flow data. I'm not going to save a new file. I'm just going to make some changes and save over this existing file. So rules. Now for minimum opening right here, I'm going to change this to a 1 foot, or maybe half a foot. Let's see if 1 foot works. And then enter data. Now for the change or the adjustment at each time step, I'm going to go ahead and just change it, this right here. I'm going to change that expression. Instead of 0.1, it's going to be 0.05. Okay. And then same thing here for lowering it. Instead of negative 0.1, it's going to be negative 0.05. And then click OK. Okay. So that looks good. Okay. File. Save. Okay, I'm going to close that. Then we can go back to the unsteady flow analysis. I could change this as well, maybe 10 minutes, and then the detailed output data, also 10 minutes. Okay, that looks good. I'm going to go File, Save, and let's go ahead and run this one once again. Okay, so I didn't see any errors. That's good. I'm going to close this. Let's go ahead and take a look at some cross-section data. I'm going to go ahead and run the animation now at River Station 1000. Options, Animate. And then actually, I'm going to speed this up a little bit because we have a few extra time steps and play. All right, so we're starting off at an elevation of 36. Then at the beginning of day 2, right there, it raises to 38. And then at the beginning of day 3, boom, up to 40. All right, cool. So no stability issues. The changes that we made apparently helped for keep the model running. Let's do a couple other things while we're here. Let's look at River Station 500 and just confirm that we don't have any time steps of zero flow. So click animate here and then play. I assume the water's going to probably just be right down here at about 32 or 33 feet the whole time. And it looks like that's good. Okay. Next, I want to take a look at the gate, which is the inline structure at River Station 950. So I'll select the inline structure, and then let's go ahead and animate that, and then play. So the gate is going to be continuously opening and closing and adjusting that 0.05 feet. And that's pretty interesting. At the beginning of day 2, the gate actually shut quite a ways, perhaps to the minimum, to let the water surface increase, and then it readjusted. Okay, so that's interesting. Let me go ahead and take a look at the actual table data. So I'm going to go up to View and then Profile Summary Table. Now I want to look at the inline structure standard table. And then for options, I want to toggle on all the profiles, but then remove this max so it starts at the first time step. Now I don't care too much about any of these columns after Q total. So I'm going to delete these columns, but then add in a column that keeps track of the gate height. So I expect that gate height to be between 1 and 4. 1 is our new minimum, remember. 4 is the maximum height of the gate. And I expect to see it drop down to 1 at the beginning of each day in order to increase the water surface upstream. All right, so options, define table. I'm going to come over here to column 4 and then just delete. All right. So what I want to insert in table column 4 here is now the gate depth. I'm going to type in gate and then height of gate opening right here. Double click and then OK. So the gate starts totally open and then it looks like it's at an equilibrium around 1.8 feet, 1.7, 1.6. Keep in mind that inflow is not constant. So the gate is adjusting based on that inflow and also based on the water surface elevation 500 feet upstream at that cross section at River Station 1000. Okay, so that's noon, 6 p.m. And then finally, here's the beginning of day 2 right here. And sure enough, the gate shuts, or at least it shuts down to the minimum of 1 foot. And then it stays shut all the way until right here, which is 3:30 a.m. So for the first 3.5 hours of the second day, the gate is set to its minimum, and the water surface increases from 36 up to about 38. This is not exactly where we want it to be, but keep in mind, this is at River Station 950, the inline structure, and we're doing the monitoring at River Station 1000. I expect to see the same thing happen at the beginning of the third day. Okay, here's the beginning of the third day, and boom, yep, it goes down to its minimum value of 1 foot, and that lasts for about 3 hours and 40 minutes. Well, anyway, lots of other things we could tinker around with. If I had more time, I would probably run some more randomly generated inflows and see how the gate responds. But for now, that's it. We created a river reach, an inline structure, a gate. We set some objectives for that gate and then created some rules to satisfy those objectives.